Here's what we're going to do. I initially thought we'd do one step and multi-step together today, but I think we'll take them, and then we were going to practice them together, but I think we'll take them a day at a time and go there, because I think if we can get the foundation here really, really strong, then it'll help us to move forward a little bit better. So we're going to talk about one-step equations. Now remember, we're in equations now, not expressions, and what's the difference? Equation has what? Okay, what else is it? What's the difference in an equation and an expression? Equal sign, right? Okay. But we have numbers, we have variables, we have all this expression. There's no equal sign equation, we have an equal sign. So what we're going to be doing, we're going to be solving for that variable that's in there, just like that one we just did from homework where it was like, I don't remember what it was, something plus x equals 91. And we'll be solving for that x, okay? So it's easy to kind of reason through, but we're going to do it algebraically. So before I start, I want to talk about some opposite operations real quick. Opposite operations. Tell me this. What
dude. Why? Just say hey.
Do not make faces out the window, Dave.
I'm not making faces out the window. I'm sorry.
What is the opposite of addition?
Why? I'm not doing anything.
Subtraction, right? The opposite of addition is subtraction. So if I had... Let's just leave it at that, and then we'll talk about it. How about, and this goes both ways. The opposite of addition is subtraction. The opposite of subtraction is addition, right?
Yeah.
How about multiplication? Division. And these are the ones that we will focus on today and for a while until we add some more stuff here. All right. Opposite operations. They're what cancels each other out. Okay, they're complete and total opposites. All right, here's what I want to do. Sorry. All right, we have this property in algebra, and this property tells us that it's called the addition property of equality. It tells us that if we have an equation, any equation, right? Any equation, then I can add whatever I want as long as I add the same thing to both sides. Anything. Long as you add the same to both sides. Does that make sense to you? I've got this equation, let's say that exact same equation that I had whenever I was doing homework just now. What was it? It was 28 plus x equals 91. This equation, whatever I want to add to both sides, I can add to both sides. Did it go away?
Uh-oh.
It's okay. So, it doesn't really matter. David, put that phone away. If I want to add 2 to both sides, I can, as long as whatever I'm adding goes to both sides, okay? This is not going to help us in solving this one. It's kind of a terrible example to use. But the point that I'm getting at is I can add anything to both sides. Now, so that it doesn't hinder us as we go through some examples, we also have along these same lines the subtraction property of equality. What do you think the subtraction property of equality says? It's the exact same thing. I can replace the word addition with subtraction, and I can replace add with subtract. Can you guess another property of equality that we have? Multiplication property. And so I could go in and I could replace all these words with multiply or multiplication. You're absolutely right, CJ. There's also division. Okay. I'm not going to rewrite all of these unless you just want me to.
Yes.
Do you? But all of those properties apply to the equation. So I can add anything as long as I add the same thing to both sides. I can subtract anything as long as I do it to both sides. I can divide by anything as long as I divide by the same thing on both sides. And I can multiply by anything as long as I multiply by the same thing on both sides. Does that make sense to you? All right. So let's look at an example of how we're going to use this. And I know most of you have had this before, and this is probably boring you because you know how to do it. All right. Let's say I have x minus 22 equals 54. Okay. Here's what I want to do. I want to look and see what's happening to x, or whatever variable there is in the equation. Okay? It's 22 is being subtracted from it, right? So what I want to do, you're exactly right. I want to do the opposite.
54 plus 22.
But if I do it, remember, I've got to use that property of equality, so I've got to do the opposite, but to both sides. So y'all are exactly right. 22 is being subtracted. The opposite of subtraction is addition.
But why make it that complicated when you can just do 54 plus 22?
That's what I'm doing.
Oh, I thought you
get rid of 22.
No, you
That's
said
right.
both sides. I thought you were adding it to that. It's not the 54, my bad.
All right, so I added to both sides this way, and the whole point in this, the whole goal that you have to remember, our goal,
Get X.
get the variable by itself. Whatever you have to do to get rid of anything that's with it, that's what you have to do to get the variable by itself. So here it's got this negative 22, so if I just add both sides. What property allows us to do that? Addition, property of equality. Now, what is negative 22 and positive 22?
0.
So it's going, right? I still have x. This is 0, so I don't have to write that. What is 54 plus 22?
76.
76. Now, this is my answer. No, we're just doing one steps today. This is my answer. Yes, George? I'm not quite done because I need to make sure I need to make sure that I got the right answer. So how do I make sure we check it? How do I check it? You put a 76 where x is in the original equation. So you plug it in. 76 minus 22 equals 54. So my question is that true? Does that work? Is 76 minus 22 54? Yes. 54 does equal 54. Yes, that works, and I am done. Does that make sense? Yeah. Probably for a little while. We'll have to show some of them. Shh, shh, shh. All right, guys. Let's do one more.
Do it.
Don't blurt it out just yet. Give everybody a chance. All right. I need to get x by itself.
I know what to do.
Can we turn on the board?
I don't know if it'll let you. You can try. Why don't you try? I don't know if it'll let you write on it since it's Bluetoothed into this time. George, you are getting louder and louder and louder, and it's not even about math.
I'm pretty good today.
No. Here, you can do it on here. All right. Shh, 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 shh. Patrick, put that phone away if you value it. All right, CJ is subtracting 63 from both sides. Make sure you get on both sides of the equal sign there. All right, so on the right side, he's got 16. On the left side, he still has X. Perfect, but he needs to check it for a little while. So does that check, is 63 plus 16 equal to 79? Yes, it absolutely is. Thank you, CJ. All right. Let's kick it up a notch, because that's what we do in math, right? We kick it up a notch.
No.
Listen, do this for me. Give me a thumbs on addition and subtraction one-step equations. Yes, I got it. I could do it in my sleep. And I'm so-so. I don't got it at all. Everybody give me a thumb, a thumb, a thumb. All right, good. All right, let's look at, let's make it a little bit harder.
Okay.
I'll start easy with the multiplication division, then we'll do.
Oh, wait, I know this one. I just did this one.
Come on. All right, don't blurt the answer out. Don't blurt the answer out. Tell me, as she comes up here to do this one, tell me what's being done to X.
Division.
No, what's being done to X right now?
Multiplication.
Multiplication, and the opposite of multiplication is
Division.
division. And why you feel all right. You sure? All right, I'm just going to come over here and check it real quick. Is 2 times 8, George, does that equal 16?
Yes.
Yes, it does. 2 times 8 is most definitely 16. All right. You knew it was coming.
I don't know how to do it. Well, then it was coming.
Now, wait just a minute, because we talked about this for a little while.
Is it?
I'm not gonna.
Good job. Good job, Xavier. Did y'all hear what she said? She said, should I multiply by the reciprocal? The answer is yes, okay? I'm going to make you a little note. Listen, I stress this. This is something I stress from this level all the way up to my pre-cal class, because everybody always forgets. When you need to get rid of a fraction, never divide by a fraction.
The reciprocals were on top, right? No, yeah.
A reciprocal is a flip.
Oh.
Because here's what happens. Remember we talked about never divide by a fraction. Instead, let me write this and then I'll talk to you just a second. Instead, multiply by reciprocal. Now remember, we can multiply both sides of our equation by anything we want to. So here's what I want you to think about. We talked about multiplicative inverse and multiplicative identity, remember? And that identity caused us to cancel out and equal 1. Anytime you multiply by reciprocals, that means you take one and then you multiply it by its flip, you always get 1. Okay? It doesn't matter what those flips are. If I have 1/2 times 2 over 1, I get 2 over 2, which is 1. Okay? If I have 4 over 7, and I multiply that by 7 over 4, I get 28 over 28, which is, anytime you multiply reciprocals, they cancel out. They give you 1. Okay? That's that identity, that inverse, I mean, right? Those are inverses. So here, because I'm multiplying by a fraction, yes, I'm multiplying, and the opposite of multiply is divide, but I do not want to divide by a fraction. Instead of dividing by a fraction, George, tell us what we do. Reciprocal. What's the reciprocal? What is the reciprocal that I need to multiply by? 3 over 2. If reciprocal confuses you, remember that just means flip it over. Okay? So on the left side, George, I get 3 times 2 is 6, and 2 times 3 is 6. 6 divided by 6 is 1, so these cancel out right here. So that was the whole goal, remember. It's 3 over 4.
Oh, that's easy.
Multiply, top times top, bottom times bottom. Now, let's check it. Let's check it. 2/3. This is where checking is really important too. Times 3/4, does it equal 1/2?
Yes.
What's 2 times 3?
7.
What?
Is that your number of the day, CJ? 7. 6. And then what's 3 times 4? 12. Does that reduce to 1/2? It sure does, so it works. I'm going to make it a little bit harder. I tell you what, CJ, nobody blurt this answer out. If you get this one.
No. Hold on, what's that? Hold on, what's the deal?
Solve it for x. Let's put a different variable so you don't get used to x all the time. We'll put c for CJ. This is his problem. Solve it for c. I'm gonna pause and. All right. So most of you, CJ, last morning, most of you figured out that right now it's a mixed number and it needs to be an improper fraction, right? How do we fix that, David?
Is it add the top and multiply the bottom?
Multiply and add. So, guys, when y'all hear me talking, y'all stop. 1 times 8 is 8, and 8 plus 3 is 11.
Does it matter what order you do it in?
And it is negative. Okay? The negative is not going to impact what you add and what you multiply. It's just going to make the whole thing negative in the end. Okay? So I have negative 11 over 8. Yeah. Yes. All right. So now that I'm in an improper fraction, I'm ready to do reciprocal. What is the reciprocal here? Negative 8 over 11. You want to carry that sign with it, okay? So negative 8 over 11. Negative 16 over 33. Does that make sense to everybody? CJ asked for one more. Let's do uno más, uno más. Allison is making a stained glass window.
Oh no. I can't stand you.
Y'all know we have to really focus on word problems because that's where George, I am fixing to move your group.
If you get George there.
Allison is making a stained glass window. Her pattern requires that 1/5 of the glass should be blue. Write down what you think you need to know as I read it. 1/5 of the glass should be blue. She has 288 square inches of blue glass. If she intends to use all of her blue glass, how much glass should she need for the entire project?
All of it.
Huh? All right, let me read it again. Listen carefully, listen carefully. Allison is making a stained glass window. Her pattern requires that 1/5 of the glass should be blue. She has 288 square inches of blue glass. If she intends to use all of her blue glass, how much glass will she need for the entire project?
Wait.
1/5 of all the glass. All right, she's making a stained glass window. Her pattern requires that 1/5 of all glass should be blue. She has 288 square inches of blue glass. She wants to use all the blue.
So, wouldn't it be 288?
How much of the other glass does she need? I told you yesterday that word is always means equal. There's another key word in here that'll help you if you know what it always means. Of. What does of always mean? Close. Multiply. Of always indicates to me to multiply. Okay? All right, so 1/5 of all the glass should be blue. What is it that I don't know? What's my unknown? The other glass, right? So I'm going to let that other glass, I'm going to let that be X. That's what I don't know. So 2/5 of what I don't know. How can I write that? Not what 2/5, 1/5. 1/5 of what I don't know. How do I write that? 1/5 X. Right? 1/5 of what I don't know. What does it equal? 288. That's how much she has. Right? Now can you solve that for X and tell me how much glass she needs? How much other glass she needs? What do you do? What's the reciprocal of 1/5? 5/1.
So it'd be 288.
Cancel out.
All right, this cancels out. That's correct. Girls. Absolutely. So how much glass does she need? What's 288 times 5? 1,000 what?
1,440.
440.
1,400.
All right.